Hello students, today I am going to discuss the linear equations included in your curriculum, in your syllabus. What do you mean by linear equation? Linear is, according to the part of speeches in English, is an adjective which is derived from the noun line. So, linear means relating to lines. The couple of straight lines that represent straight lines, two straight lines, are called linear equations. It's also called simultaneous equation. And what do you mean by equation? Line is also a geometric figure. Plane geometric figure. Triangle is a plane geometric figure. Quadrilateral is a plane geometric figure. And the equation of a plane geometric figure is nothing but the relation between the coordinates of the geometric figure on any point of it with reference to the rectangular axis. And so the linear equations represent straight lines. I told you what you mean by equation. Equation of a geometric figure is nothing but the relation between the coordinates of any point on the geometric figure with reference to the rectangular axis. If there is no rectangular axis, there is no equation. Because rectangular axis is the determinant, is the director to make a linear equation. Now, you see the linear equations. The coefficients of the linear equations determine the directions of the coefficients of the linear equations determine their directions. Here, the coefficients of the variables of the linear equations make the two lines vectors. And you see, if the coordinates of the variables of the linear equations are not proportional, they must represent straight lines intersecting at a point, at a single point, to give unique solution. For example, you see, I cite some numerical example. If Hori consumes 3 berries and Madhu consumes 5 berries, what's the total berries they consume? And the answer is 8, and only 8. It cannot be something less or something more than 8. Because the straight lines intersect at a point with proportional coefficients. You see, the role of the coefficients of the variables in the linear equations. They act like a balance of a vehicle. They lend the straight lines a certain direction, a sense of direction. Do you follow me? But on the contrary, you see, and for that point of view, as these straight lines intersect at a single point, they do agree in one point to each other. In one point, only in one point. So, these straight lines give unique solution. One which is unique, one and identical. Because the variables bear the improportional fractions of coefficients. You see, here only one point. So, the coefficients of the intersecting lines cannot at all be proportional because they do not agree in more than 1 point. If they would agree in more than 1 point, the solution must have been innumerable. So you see the conditions. Determine the unique solution. A1 by A2 is not equal to B1 by B2. Do you follow? A1 by A2 is not equal to B by B2. Because the statement is very interesting. Mathematics is very interesting if and only if you can find interest in it. A1 by A2 is not equal to B1 by B2. Because the state lines do not agree in more than 1 point to each other. So they give unique solution. On the other hand, if they are coincident, if the linear equations are coincident, that means one overlaps the other, then they must agree in more than 1 point. They overlap. The state lines overlap, and they agree in more than 1 point, in innumerable points. So the solution is innumerable. For example, if Hori consumes 4 berries and Madhu to more than Hari. Sorry, if Hori consumes some berries and Madhu more than Hari, what would be the total number of berries both of them consume? It must be innumerable, because if Hori consumes 1, Madhu consumes 1 plus 4, 5. If Hori consumes 2 berries, Madhu consumes 4 plus 2, 6 berries. If Hori consumes 3, Madhu consumes 4 plus 3, 7 berries. Do you follow? So on and so on. And they give innumerable solutions, because here the state lines representing the linear equations agree to each other in innumerable points. You see, yeah, this state line agrees with this state line in innumerable points. So the solution is innumerable. And here the coefficients of the variables. Must be proportional, including the constant. You see, the role of constant in the linear equations is not less than the coefficients. Here, the constants are here, proportional to the coefficients. The constants are also proportional to the coefficients, so that the two straight lines agree in innumerable points to each other. And so, including the constants, the fraction of the coefficients are proportional, including the constants. And the lines are called coincident. They coincide with each other. What do you mean by coincidence? To merge a small straight line merges with a large straight line. Here you get innumerable points. And I said to the example, if Hori consumes some berries and Madhu for more than Hari, what is the total number of berries they consume? It must be innumerable, because if Hori consumes 1 berry Madhu consumes 1 plus 4, 5 berries. If Hori consumes 2 berries, Madhu consumes 2 plus 4 is equal to 6 berries, so on and so on. And you see how the linear equations, the coefficients of the linear equations determine their directions. Unique solution, innumerable solution, and no solution. And on the other hand, if the lines do not intersect each other and remain parallel, here the solutions are coming out of their intersections. Here the points of intersection is innumerable. So these straight lines give innumerable solutions. But here the point of intersection is only one. So the intersecting straight lines give unique solution. But if, on the contrary, the straight lines are parallel, you see, the coefficients of the variables must be proportional. But the constants won't bear any proportion with them. Do you follow? Here you see the second case gives innumerable solutions. And because the constants bear a proportion with the coefficients of the variables. If here, you see, the constants do not pose a proportion with the coefficients of the variables. So, here, the coefficients of the bearing of a proportion with the variables of the coefficients of the constants indicates agreement. Indicates agreement in innumerable points. How important is the role played by the constants in the linear equations you see. And so, in the second case, A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. You see clearly, and bear it in mind, the role of the constants is not lesser than the coefficients of the variables. Here, because the constants bear a proportion with the coefficients of the variables, the line give innumerable solutions. But you see, in the first case, the coefficients of the variables of parallel, what to speak of the constants, the coefficients of the variables do not bear a proportion, do not pose a proportion. There, the fractions posed by the variables of the coefficients are not proportional. Because, you see, they are very important, because the straight lines agree only one point. They do not agree in more than one point. In their run, they do not agree in more than one point. So, they give only one solution, unique solution. And I say to the example, if Hori consumes 4 berries, and the Madhu 5 berries, the total number of berries they consume is 8. It's only 8 and 8. It cannot be something more or something less than 8. So the solution is unique. It's very interesting remark. But if on the other hand, the coefficients of the variables are proportional along with the constants, they pose total agreement. One straight line agrees wholeheartedly with the other. One straight line agrees with the other wholeheartedly. The smaller straight line agrees with the larger wholeheartedly. And such an agreement produces innumerable solutions. And I said the example, if Hari consumes some berries and the Madhu consumes 2 more than him, then the total number of berries they consume would be innumerable. If Hori consumes 1, Madhu consumes 3. If Hori consumes 2, Madhu consumes 5, so on and so on. So the solution is not 1. The solution, on the other hand, is innumerable. You cannot number the solutions because 2 straight lines have, when overlap with each other, when coincident, they agree with each other in innumerable points. However small the straight lines may be immaterial, whether they are smaller or greater. But if one straight line, a small straight line, overlaps a large one, the solution are innumerable because the straight lines have a smaller, agree with many points. So the solutions are innumerable. See, and if on the other hand the lines are parallel, they give no solution because even they do not agree with 1 point. They are arbitrary. They do not want to pose any agreement, any deal. They are arbitrary. They are pure dictatorial attitude. And no one agrees to the other. And I now cite some numerical examples. If Hori consumes some berries and Madhu consumes some berries, what's the total number of berries they consume? Can we answer? No, it doesn't have any answer. Because Hori consumes some berries and Madhu consumes some berries. They do not agree with each other even in a single point. Even in a single point, they are arbitrary. They do not pose any agreement with each other, any deal. And they move as per the sweet will in defiance of each other's agreement, in defiance of each other's agreement. And so here A1 upon B1 is equal to A1 upon B2 is not equal to C1 by C2. You know how important is the role of the coefficients in determining the direction of the straight lines. In the second place, in this second case, the coefficients, the constants, they are proportions with the coefficients of the variables. So they give innumerable solutions. But here, A1 is equal to B1, A1 is equal to A2 upon B2 is not equal to C1 upon C2. Here is an agreement. The endpoint of this line agrees to that of the larger one. And here they agree in 1 point. Here you see the distance between them is same because the parallel lines give the same distance with each other to any distance. Whatever distance they cover, they keep the same distance between them. So